So welcome to Engineering 844 final project presentations. This has been a great experience for all of us going through this course, and finally we have come to the last day. And I would like to give a very brief introduction what this course is about and what we are doing as first projects. The Embedded System Design course is a course that tries to teach students the concepts of embedded system design and integration involving both hardware and software development. In this course we use a platform called D2115 TPAD board. It's an FPGA board. It hosts an Altera FPGA chip on it, and it provides many I/O ports, and as well as a touch panel display. So this enables us to integrate all kinds of I/Os that might be used in embedded systems. So students are asked to implement a comprehensive embedded system design project, and the requirements are the project must have hardware and software component. And another requirement is that the project must involve a video output. It has to have a video component being displayed on the TPAD display. Another requirement is that there must be some touch functionality incorporated into the design. And the students are also encouraged to make use of all available I/O ports on the board. And we've had about we've had 36 students in the class, and they have formed teams of maximum 4 students, and we have a total of 13 projects to present today. So with that introduction, I hope you will enjoy the presentations today.
So, hello everybody. Our project is real-time color recognition and tracking. The team members are myself, Saurabh, Americo, and Oleg. So, our project idea came from our senior project that we did, which was a robot which can do color recognition. So, we wanted to improve on that idea and make a application which would do real-time color recognition as well as tracking, and also use the touchpad interface to do have a user interface where the user can choose color and all that. So this is the basic hardware design. We are using the VGA output. We have the HSMC, which is connected to the touchpad, and the GPIO is connected to the camera. This is the extension that we have to use for our LCD. And now Americo will explain, Oleg will explain the
I quickly go over the color detection flowchart. We started with an example that Terasic provided, which basically took an image and displayed it on the VGA. What we did end up doing is, so this part's kind of what we did right here. We kind of stuck it in the flow. The color detect is a thing that actually tracks finds the ball, tracks it. It has PIOs that are connected to the processor, and the processor also controls the LCD touchpad. That's what our SFPC builder looks like, and it's pretty much a CPU and things that require the touchscreen to work. This is how I'm doing color detection. This is a formula I'm using to figure out how close color is to what color we're searching for. So red average is some color we set up, and then the in red is whatever the pixel is. And you square them, add them together. You're supposed to take the square root of it to get the distance, but square rooting takes a lot of processing power, so we decided just to leave it as a whole. And then we have a more or less simple if statement saying that if the pixel, the square value is less than some control that we set up, the pixel is considered a hit, otherwise the pixel is a miss. And then there's a little bit more filtering that goes on that pretty much finds the ball. There goes a little bit about the software.
All right. Hello everyone. So we actually only use 3 HDLs. We use the touch panel HDL from Jurassic, and we use from Altera to read the PIOs and for the char buffer. The camera is actually rendered in Verilog. It's purely hardware. We decided to go just for hardware to improve the speed, be able to read as many frames as possible. Everything else is done in software. We also have PIOs coming from the camera to the processor to control the camera. So as soon as we start up our system, we initialize the char buffer and touch screen and all the variables we need. And a welcome screen is displayed, just saying basically who this project does, who we are, and it's waiting for the user to touch to continue. Once you touch the screen, the main window appears where you have different options. So first of all, which color does our system track? And the answer is that you can track whatever color you want. There's a button that says mode selection. When you press the mode selection, it goes into color sampling mode, which means there's a little square in the middle of the screen. You place the object you want to trace right in the square, and you press the button again. From that point on, the system is tracking that color alone. Once you have the tracking, you can see your object and the crosshair superimposed to it. That basically shows you that the system is actually tracking your object. The other option we have is to start a little game that we put in there. Once you press the start game button, a small yellow square appears at a random position on the screen. And the goal of the game is to basically move your object and the crosshair that's tracking it towards the square. Once you hit the square disappears and pops up somewhere else randomly. Then when you have it set up, you have to go through 10 squares. Once you're done, the total time that you have taken appears on the screen, and there's also a record feature that shows who's been the fastest since when you turned on the system. Other than that, the different PIOs that we have coming from the processor display the RGB value, the color you're tracking, the X and Y distance that you are from your target, and as well as how much time you've taken so far to go through the squares. And after this, we're ready to show you the demonstration.
You could actually, otherwise you have to move the other way before, but that messed up